Okay, welcome to this walkthrough of Mastery Exam EL Practice Version 2. Like the other Practice Version 2 screencasts, we're not going to dwell a lot on some of the details behind the problems you see here, just a few quick mentions about how things are working. If you want to know more of these details, you can go back and look at the Practice Version 1 screencasts, where we do go into some more depth. And also, just take some notes, write down some questions, and shoot them to your professor, and we'll get it all straightened out. So on to problem 1 here, we're simplifying completely this expression on the here, x to the first to the sixth times x squared to the 1/4. So we're just going to work from the inside out here is the main idea. So looking at the innermost thing here, x to the first to the sixth, this is a situation where I have a base raised to an exponent and then immediately raised to another exponent. So I'm going to multiply those exponents together. And so now on the inside of the parentheses, I now have x to the sixth times x to the 2 all to the 1/4. Okay, now I can start working some more. On the inside here, the parentheses, I have same base, different exponents, so I'm going to add those things together. That's x to the 8th. And once again, I have a situation where I have two exponents in a row, so I'm going to multiply the exponent. So it's x to the 8 times a fourth is 8/4, which is of course the same thing as x squared. Okay, and that's the end of that problem. Moving on to problem 2 here, just like in screencast for the practice version 1 version of EL, we're going to do all 5 of these at once since they basically all involve the same rules. Just to remind myself what that rule is, when I write log base A of x equals y, remember that means the exact same thing as a to the y equals x. So let's put that to the test right now. What is the log base 8 of 512? So in other words, what would I raise 8 to get 512? Knowing that these are mastery exams and we're not supposed to use technology, a lot of times you can just guess at what these are. I know 8 squared is 64. And let's see what 8 cubed is. That would be 64 times 8. And that actually does come out to be 512. So 8 to the third power is 512. And so my answer here is 3, because 8 to the third is 512. Now I'm going to get rid of this work here. And let's move on to the next part. 9 to the what power would give me cube root of 9? That's what this is asking, the log base 9 of cube root of 9. So 9 to the what power would give me cube root of 9? Well, it's helpful here to rewrite this root, this cube root, as a fractional exponent. So it would be 9 to the 1/3. That's what a cube root is. And that tells you immediately that what's supposed to go in the blank is 1/3. So my answer, my logarithm, is 1/3. Moving on to part C, the log base 2 of 1/8. Again, that's just asking the same thing as 2 to the what is 1/8. Well, I know 2 to the third power is 8. So if I want 1/8, I need a negative 3 power. So 2 to the negative 3 is the same thing as 1 over 2 to the 3, and that's 1 over 8. All right, so my exponent is going to be my answer. That's negative 3, because 2 to the negative third power is 1/8. Okay, now let's move on to these last couple of parts here. What is the natural logarithm of e to the negative fifth power? This goes back to a rule that we discussed in the first screencast for practice version 1, that ln of e to the anything power is just anything. That's an a, not a 0 there. And so the answer here is going to be negative 5, because the ln composed with the e to the negative fifth, the ln and the e cancel each other out. Similarly, right here, e to the natural log 1, there's a flip side of this. E to the natural log of anything is going to be the anything. The e and the natural logarithm cancel out again, so the answer here is 1. Those involves knowledge of some exponent properties and exponent laws, and again, don't have time to go into those here in the screencast, so you might want to go back and review and ask your professor about those laws, ask your Math Study Center tutor about those laws, and get those straight. That's what these are all based on. Moving on to the next problem, we were going to write the following expression as a single logarithm. These are all the same base logarithms, so I'm just going to use some rules to simplify things. This, we saw a rule before about this. This term is the same as log base 5 of x cubed. This term right here is the same as log base 5 of y squared. Nothing to do with this one. I'm subtracting these two So if I were subtracting these, I would combine those into one logarithm, log base 5 of x cubed over y squared. And remember, I am adding log base 5 of z. And so that means I'm going to multiply inside the logarithms. So we have log base 5 of, and this is going to be my final answer, x cubed times z over y squared. And that's the end of that problem. Now on to the two equation solving questions that are on Master Exam EL. We're going to solve the equation 10 e to the negative 3x equals 11. So x is up here in an exponent. I'm probably going to involve a logarithm to get that x out. So first I'm going to divide off the 10. So I have e to the negative 3x equals 11 tenths. And now I can apply the natural logarithm to both sides. I'll just kind of write the sort of skeleton of that, applying natural logarithm to both sides. So e to the negative 3x and 11 tenths. And then on the left-hand side, I'm going to use a cancellation property that we saw back up in problem 2. Natural log of e to the anything, to the negative 3x, is just the anything. So I have negative 3x, after canceling the natural log in e, equals ln of 11 tenths. Now to solve for x, I'm just going to divide by negative 3, and my x is going to be negative 1/3 ln 11 tenths. Or same thing, you could write it as negative natural log 11 tenths, the whole thing over 3. Same answer both ways. Second equation here, the next to last problem on EL, I'm going to find the exact solution or solutions to this equation, negative 2 ln natural log of 1 minus x equals 10. Okay, the x this time is kind of buried inside a natural logarithm, so raising something to an e power, or to the power with e as a base, as a power on e, is probably going to be the right method here. But first I need to divide off the negative 2 so I can get that natural logarithm by itself. So natural logarithm 1 minus x, by dividing off the negative 2, divide the right side by negative 2 and I get minus 5. Now I need to do something to both sides of the equation, so here again, I'll just highlight this in red what I'm doing. I'm going to raise both sides up as a power on the number e. So I have e to the negative 5th on this side and e to the natural log 1 minus x on this side. Just doing something to both sides of an equation. Now what's nice is the cancellation property that kicks in will tell me that e to the log of this stuff is just going to be that stuff. That's cancellation property. And on the right hand side I have e to the negative 5th left over. So now to solve for x, I think I'll add x to both sides. That will give me 1 equals e to the negative 5th plus x, and then subtract off this e to the negative 5th. That gives me a final answer of 1 minus e to the negative 5th power, and that's when I'm done. Just want to mention one more thing here about this problem. This is a correct answer on the answer guide that's posted to the internet. It also lists the answer as 1 minus 1 over e to the 5th. Now just realize that e to the negative 5th is the same thing as 1 over e to the 5th. In fact, when I take x to the negative a power anytime, it's 1 over x to the a. So both of these answers are equally correct, they're just in slightly different forms. Okay, so last problem on this exam here. Let's rewrite this expression, log base 10 to 42, as an expression involving only the natural logarithm. This is a simple application, direct application of the change of base formula, which we discussed in the practice version 1 screencast. We're just going to do this very quickly. This is equal to the natural log of 42, the thing I was taking the log over here, divided by the natural log of the base that I was using over here. So that's my answer. This is an expression that involves only the natural logarithm and nothing else. And that will do it for exam EL. Again, send your questions to your professor and get some help on this if you need it.